homework 04-12. It's the same kind of problem. Find the amount of work in joules done on the surroundings when 4.09 liters of an ideal gas, initially at a pressure, is allowed to expand to a larger volume by reducing the external pressure in 2 steps. We start at 5.94 atmospheres and then we change it to 3.17 atmospheres. And in order to do this problem, you'll need to calculate the intermediate volume using P1V1 equals P2V2, a gas law that we will talk about in more detail coming up, and then to 1.59 atmospheres. Your answer is the sum of the work for both pressure changes. And let's start with A. For A, let's see. So we start at 5.94 atmospheres, but the starting pressure is never something we use in the calculations as far as work. So let me see, work. It's going to equal minus P times the change in volume. The first pressure is going to be 3.17 atmospheres. We start with 4.09 liters. So 4.09 liters is going to be our volume initial. And this 15.31 liters is going to be our final volume down here. So in order to keep things a little more organized, I'm going to write that this is my volume initial for A, and that this is my volume final for part B, liters. And what the problem says is you need to calculate the intermediate volume, and the intermediate volume is going to be the volume that goes with 3.17 atmospheres. So P1V1 equals P2V2. Now we do need this 5.94 atmospheres. So, and our initial pressure goes with our initial volume. Our final, or our 3.17 ATM goes with our, what we could call V, and I kind of ran out of space here. There, I'll bring out my auxiliary paper. V final A. And this will also be V initial B because it goes with this intermediate pressure. Anyway, so solving this, V final A is going to equal 2 numbers here divided by the 3.17. Divided by 3.17, I get 7.66 liters. So again, still working on A here. Let me create some more space. My V final for part A is 7.66 liters. My V initial is 4.09. And calculating this all out. So I'm going to do my subtraction first for my liters, 7.66 minus 4.09. I get 3.57 times the 3.17, and I'll put in my minus. I get minus 11.3 liter atmospheres. And this is my work for A. And so I will call it work sub A. That's an A. Now doing the same thing for step B, and I'll put in my A's here, and now I have work for step B, minus P delta V, where my pressure now is always going to be my final pressure. And I have my final volume for B, and my initial volume for B is my final volume for A. See if I can put my pieces of paper back together again here. Close anyway. Subtracting my volumes. I get 7.65 liters times 1.59 atmospheres minus 12.2 liter atmospheres, which I can then add up to get my total work. Work A plus work B minus 11.3 plus minus 12.2 and I get 23.5 minus 23.5 liter atmospheres, which again I can multiply, and I should multiply, and I will check to see if it works out, times 101.325, 23.5 times 101.325, I get minus 2,381 joules of work that was done by the gas. Selden, I don't know if, did you have a chance to do this problem too, or give it a shot? Or anybody?
I'm working on it right now.
Good.